Hey everybody, as always, welcome back to the show. So we're on engine number 2 of 3 of the old tri build, and the goal tonight is to get that one turned into a short block. And we pretty much did a comprehensive run through on the first one, so most of it will be a little light on the details. We'll go through and touch on just a couple of things that are particular to the very first gen old school setup we have going on right here, but that's not really the primary goal of the episode. We're going to kind of talk through, well, a common theme that I've seen coming up in the comment section to people that are new to the vintage Caterpillars and these starting engines. I'm trying to think of how to nutshell this in an efficient manner. Basically, a lot of people are becoming of the opinion that, wow, those starting engines were really bad. So, that's not really my opinion of them. However, they are extremely basic, about as basic as you can make an internal combustion engine for a variety of reasons we'll touch on. But at the end of this, I'll give you my opinion as to how quote unquote bad they really were, if they were in fact bad at all. So let's start putting some pieces in there. First things first, before we set the crank in, get everything good and covered with the assembly grease. Can't have too much of it. And just like last time, seal washer goes on. Followed by the woodruff keys. With the gear pressed on next, timing marks aligned. And secured with the heavy washer, the 2 bolts, and a properly folded lock, of course. Block flipped around for this quick check. Rear cover on temporarily with just 2 bolts so we can support the crank enough to get a good dial indicator reading. Now I machined my new bearing to give us a 10 thousandths in-play measurement. 10 to 15 is desired spec. We were 10 before, but we've made that permanent. I want to check this before moving on. So, was 10, still 10. Good to proceed. Piston and rod assemblies up next. As I've mentioned in the past, I like to use the inside bore gauge on these rods with the bearings in and the external mic on the journals to verify my running clearance, because plastic gauge is kind of tight working inside there. Bearing clearances are all perfect. So what have we got here? I've got a good set of used rods that my machine shop reconditioned the big ends, and they also fitted the new old stock wrist pins and pin bushings that I sourced from Floor & Tractor in California. Awesome guys to work with. They got all kinds of good stuff for these rebuilds. Along with that, Floor & also provided me with some new old stock compression rings. All these rings have been gapped to the cylinders, side clearance checked. My local Ziegler Caterpillar dealer still had the new oil control rings in stock, so that's where I picked those up. And the pistons. Beautiful first generation, new old stock, standard size from Floor & plug style pistons with the plugs still in the genuine Caterpillar part envelopes. It's going to be tough to even put these to use. They're so cool. They just go inside the piston, one on each side of the pin, and they just float along in there with everything else. Yeah, we got these pistons just like this, covered in cosmoline, wrapped in ex-military packaging. How could you not love something like that? So, are these plug style pistons like the highest level design we could use? No. Are they the best for longevity? No. Circlips are a lot better to hold pins in, but are they first generation coolness? Yeah. New old stock? Yeah. Right and proper to a first gen block? Yeah. That's right and proper to a first gen D2? Yeah. I guess our hands are just tied now, aren't they? All right, piston and rod assemblies in, everything's torqued down, everything's cotter pinned. We did the spin test, it's all good. So we can put the rear cover on. All right, everybody, we're almost done. Camshaft goes in next. Be sure to line the timing marks. And last step, slide the tappets up to the cam. And secure the valves. And we've got another short block. So there it is. That's about the simplest short block you're ever going to knock together. 2 cylinders, flathead design, flat tappet cam, clunky straight cut gear train on the timing components. It's just basic. All right, there's nothing fancy at all about this engine. And yeah, we've reworked this one a bit, and we've tried to overcome a few of the common problems you see in these, some of the more typical failures. But yeah, it is a very basic design. And in the comment section, a lot of people have started just kind of pointing out how those things just seem like they're just really poor quality from the start, almost planned obsolescence. And another person raised a good point. He asked, why didn't Cat just go like with a pressure pump, a pressure oil feed system in those? It would have made them last so much longer than like a 1 quart crankcase capacity that runs at 3,000 RPM and is splash lube only. Well, you have to ask yourself, how good did it really need to be at the end of the day? I mean, I've got this one just sitting here because that's the best storage spot that I could find. But yeah, it's just plumbed into the diesel's cooling system. It does not share any of the oiling system, and it's just in place to crank that diesel engine over for however long it needed to crank. Also warms the coolant. It generates heat from engine compression. And well, yeah, it's just a really basic setup. So let's just let's see how this thing looks on paper. So let's just figure what an average like startup cranking time would be on one of these old diesel engines. If you're in a really warm environment, I mean, 1.5 minutes, 2 minutes with a good diesel engine, you could probably get the thing started and make it run. Really, really cold environment, first start of the day, you might crank on that 12 minutes, 15 minutes maybe. Just for the sake of conversation, let's say an average start on paper would be a 5-minute cranking time on one of these old diesel engines. So 5 minutes per start to make 1 hour, that's 12 starts, 60 minutes. So 12 starts in an hour. That's our average, all right? And these engines were designed around a 250-hour service life. Now, I know that sounds really, really bad, but if you can get 12 starts an hour, that's 3,000 starts in 250 hours. So that's sounding not too bad. And this is, again, ideal world, you know. But so of those 3,000 starts, you have to then take into account how long would this thing have ran between each one of those starts. Now, when these machines were brand new, it wasn't unheard of for them to be started in the morning and not shut off until the end of the day or into the shift. If you could do 3,000 starts at 8-hour shifts apiece, that's 24,000 hours on the machine total by the time that starting engine has reached its 250-hour expiration date. Now, I know that's pushing it a little bit because we don't live in an ideal world, and you can't bank on every startup that's, you know, done with that starting engine is going to last 8 hours. So even if you cut it down a 4-hour average, that's still 12,000 hours total on the machine. And this is back when an undercarriage you could get 3,000 hours out of it. If you were in the woods or dozing, probably less. If you were in the field, probably more. I would say 3,000, 3,500 hours was probably a decent estimate for life of the undercarriage. And engine, I've heard some figures that say well maintained and, you know, in a clean, rather clean environment, again, continuous load, it's not getting beat in the woods. Maybe we're doing tillage work, 10,000 hours to an overhaul interval if everything went really well. I mean, you know, of course, your mileage may vary, but you also have clutch wear to take into account. I don't know how many hours you can get on a main clutch, especially being a dry clutch. Probably not that many. Well, you could probably do 10. I don't know about steering clutches. It all depends. If you're in a field and you're going around and around in circles, you're going to wear out one steering clutch and hardly touch the other. I mean, there's all kinds of variables, all kinds of other things that would have probably had a shorter lifespan than this poor old bare bones basic starting engine that was hung back there, assuming everything was maintained. It always had clean oil. It always had proper oil level. And you could get the operators to keep the gasoline out of the crankcase. And actually, back in the day, that 8-hour shift probably wasn't that far-fetched. My buddy Bill, he's another guy in the Antique Caterpillar Club, retired cat skinner. And I call him Cat Skinner. He was back in the day before they called them operators. He was a cat skinner. I mean, he was in the glory days too, at least what I would consider to be the glory days, 2U-D8s, pulling cable pans and everything else. Pusher cats, I mean, I would give anything to go back and just be able to do that for a week. I can probably say that because I never had to. It would be fun for me, but you know. But anyway, he would tell a story where he said he could get frustrated at some of the other operators on site because they would go around in the mornings and they'd be fueling up the machines and getting everything started and ready. And those D8s were a lot like my RD6, where the starting engine fuel tank was actually like up on top of the engine toward the front, like right here. It's probably like a gallon or so tank. And a couple of the operators insisted that thing had to be filled up to the top every morning. And it would kind of frustrate him a little bit because he said most times he'd throw like a cup of gas in the tank on his machine. And that's all you really needed to get the thing started at the beginning of the day. And he said, we never shut them off until the end of shift. And the guys that filled that little tank completely up always had a bone dry tank just like him by the next morning, because all that engine heat and everything pretty much evaporated all that excess gas off that they didn't have to burn by getting a thing started with the starting engine. And it was all a waste. But that's just a real world example of how back in the day a lot of these machines were started at the beginning of the day and they ran all day long before they ever got shut off. So it doesn't take a whole lot of cranking time on a starting engine to accumulate a lot of operating hours on a tractor. But like I said, that was probably the closest real world example that I could think of that perfect world, we'll say, box that the CAT engineers, I believe, built these little engines to operate within. I personally believe they fulfilled all the requirements and they ran as well as they needed to run. So yeah, there's a lot of design improvements that could have been done here. It could have been built with more longevity in mind. There could have been a lot of higher quality components put in here, a lot of higher tech even for back in the day. But you have to keep in mind, it didn't need to have all of that. Okay, this had to be cheap. This had to be the standard base starting option. It had to be cheaper than direct electric start. So you throw in an electric starter, a switch, some cables, and a battery. This had to be cheaper than that, all right? And it had to run. I mean, there's a lot more to this than just a direct electric start, but it's so simple and it was so mass produced. It was easy and cheap to rebuild. And a lot of people ask, like, if the CAT dealer back in the day would have encountered a spun and damaged bearing bore in a block, how would they have fixed that? They'd have just thrown a new block at it. Okay, it would have been cheaper than trying to line bore and custom turn a bearing and do all this other stuff and improve the retention methods, and they wouldn't have worried about all that because it was so cheap, easy, and quick just to start over with new components. That's what they would have done. But we're several decades removed from that, and these have endured a lot of decades of neglect, poor maintenance, abuse, and very questionable, we'll say, overhauls. You know, if someone doesn't have a lot to put in it, or it wasn't really deemed to be worth investing a lot in, as a lot of these machines had happen as they became technically obsolete, but they still ran. Yeah, they just made the thing, you know, start and run and get the diesel going, and they did whatever they had to do to pull that off, whether it was returning everything to proper spec or getting it just good enough and it was going to run. So yeah, all of our parts are about 30 years, 40 years completely out of production for this now too. So it's getting harder and harder to do rebuilds on these. And that's why we treat them now with kid gloves. Okay, we always make sure we always have clean oil. Check the oil every time before you start it without fail. Never use the mag switch. Always shut the gas off to stall these out, to shut them down, basically. That's the one thing that I would say the new operators to the vintage CATs, that's the one mistake they make the most, at least from the things I've seen in the forums and from the comments section under my own channel. You know, until it's such a simple thing, but just not turning the gas off on these with that little Zenith downdraft carburetor has blown up more of these starting engines, I think, probably than anything else. And this is going to be a controversial opinion, but it's how I really feel. The majority of people that really don't like starting engines, that just badmouth them and hate them and have always had bad luck with them, I honestly believe it's because they've never ran one that's been in good, proper form. It's never been completely right and been reliable and easy to start and easy to run and easy to operate. And yeah, if you fought something continually and it's never gotten any better and it's always a complete pain, yeah, I can see where you'd hate it and you just want to hit that electric start button and be good to go. But man, I love the starting engine personally. I like being able to crank the diesel for as long as I want. I like to be able to preheat the coolant. I like to be able to preheat the combustion chambers. The later ones actually pipe the starting engine exhaust through the intake. It doesn't go into the intake, but it's a hot tube that goes through the diesel intake manifold and exits out the other side. So you're even drawing heat off of that starting engine exhaust, further warming your diesel. To me, it's just, you're building oil pressure and fuel pressure and getting your temps up before you even put a load on anything. To me, a starting engine is the way to go. You don't get any better. You're completely self-contained. You're not worried about a battery. They're all hand crank or rope startable. I just love them. So, my opinion on the matter, I like the starting engines. I wouldn't say that they're bad. I do believe they were only built to be as good as they needed to be without anything extra. But yeah, there's a lot of things that could have been improved. Some things I am trying to improve, and what's perfect at the end of the day? Nothing. So everything's going to be a give and take no matter which way you go. So what's your opinion on the matter? I know everybody has an opinion and they like to share. So post it up below. I like that back and forth debate, the technical discussion, the different ideas, viewpoints, things like that. So now that we've got all that out of the way, that's short block number 2 of 3 of the tri-build series. That leaves us with 1. So I'm going to try some rather, we'll say, creative crankshaft in-thrust modifications on this one because the block's already not perfect, and well, we'll get into all that next time. So thanks for watching, everybody. Hopefully that didn't get too long-winded for you. Till next time.